All right. So we've already talked about some relationships previously. We know C is the cost function. And when you do the derivative of that, you get marginal cost. So that tells you how the cost function is changing. All right. So we know marginal cost is the derivative of the cost function. Now, cost is like the expense for the person making it, okay? But we know in business there's more than just how much it costs you to make it. You know, you have to decide what price are you going to charge other people for a good. So lowercase p is denoted as the price function. That's what you're selling it for. Sometimes that's also called the demand function. So either price or demand. All right, so revenue is the amount of money you bring in. So if I'm selling 10 items for $50 each to get the amount of money I bring in, what would you do? 10 items, sell them for $50 each. Multiply it, right? So in general, revenue is X times P of X. X is the number of items we sell times the price per item. So that's revenue. Then the derivative of revenue is your marginal revenue. It tells you how revenue is changing. So if it's increasing, it tells us that we are increasing our revenue as we sell more items. If it starts decreasing, what does that mean? We are losing money as we sell more items. All right. Profit. What is profit? Right. So to find the amount we make after expenses, and the notation capital P is for profit. I know it's kind of unfortunate. They use lowercase p for price and capital P for profit. I didn't choose the lettering, so it is what it is. But to find your profit, you have to take your revenue, the amount of money you bring in, minus your cost, the amount of money you spend. Marginal profit, our derivative in profit, is our P prime. So we can talk about marginal cost, marginal revenue, marginal profit. It's just how those items are changing as we increase our production. So let's look at a problem using this stuff. Suppose the cost of publishing a book is $10,000 to set up a press run, plus $8 for each book printed. So this is my cost, $10,000 to set up, plus $8 for each book. What would I write there? Could we come up with an equation?
8x plus 2,000.
Mm-hmm. So my cost, use C of X. It's just linear, $8 for each book, so 8x, plus the one-time $10,000 to set up. All right, the publisher sold 7,000 copies last year for $13 each. But sales dropped to 5,000 copies this year when the price was raised to $15 per copy. Assume up to 10,000 copies can be printed in a single press run. How many copies should be printed, and what should the selling price of each copy be to maximize this year's profit? So I'm trying to maximize profit. So that means I have to get a profit function. We have a lot of work to get there, though. How do we find profit?
Revenue minus cost.
Mm-hmm. I have cost, but I don't have revenue. How do we get revenue? Right, we have to have price times the quantity. So we need to first get a price equation, don't we? So let's talk about that. Okay. 7,000 copies for $13 each. 5,000 copies for $15 each. What would I do with this information?
Uses like points and find medium or not medium.
The slope.
Thank you. Sorry.
So X here is the number of copies, or the number of books. Okay, we already used that in our cost function. X was the number of books. So we have to keep that throughout. So when I write my order pairs, the X has to be the number of books or the number of copies. So 7,000. And my price, my Y value, was $13. When my number of books was 5,000, my price was $15. So now I have 2 points. We can write the equation. We need to do our slope. Y2 minus Y1 over X2 minus X1 . So my slope is negative 1 over 1,000. All right, think back to your algebra days. Take a point in the slope and plug into y equals mx plus b. So my y is 13. And negative 1 over 1,000 times x, which is 7,000, plus b. So my y-intercept is b. So my price, lowercase p, is negative 1 over 1,000x plus 20. All right. So far, we haven't done any calculus. This is all algebra, writing equations of lines. But important piece here is labeling. Now, we have a lot of different things. We already have an equation for cost. Now we have an equation for price. I'm wanting to get profit, so I need to get the equation for revenue. So labeling will be very helpful here. Revenue is the amount of money you bring in. We know we're selling X copies of the book, and our P of X is their price. So it's just X times P of X. So our revenue would be negative 1 over 1,000 X squared plus 20X. Everybody with me? My ultimate goal, maximize profit, so I have to get the profit equation. Profit is the amount you bring in minus the amount you spend, so revenue minus cost. But now I have both of these things. My revenue, 1 over 1,000x squared plus 20x, minus my cost, which we had at the very beginning, 8x plus 10,000. So profit, that's capital P, is negative 1 over 1,000x squared plus 12x minus 10,000. So all of my work to this point has been to get this equation. This is where calculus comes in. Anytime I ask for a maximum or a minimum, what do we have to do? We need our derivative and find out when it's 0. Alright, so bring down the 2, negative 1 over 1,000 times 2 would be negative 1 over 500. Subtract 1 from the power such as x. Derivative of 12x would be 12. Derivative of 10,000 is 0. So we do our derivative equal to 0. Multiply it by negative 500. We get 6,000. So the question was, how many copies? Remember, x is the number of copies, and we just found x equals 6,000. So we will maximize our profit, the most profit we can get, at 6,000 copies. And what should the selling price be? How do I find my price from that?
6,000 back into the price equation.
Yeah, we found the price equation right here. So if I plug my 6,000 in. So we get $14. So if we want to maximize our profit, we're going to charge $14 a piece for these books, and that should allow us to sell 6,000 copies. So a fairly involved problem, but at the same time, from a calculus aspect, there wasn't a whole lot of calculus there. It was just writing equations. What questions do you guys have there? Take a second, read the next question, and see if you have any thoughts on where we should go. So a store has been selling 200 food processors at $350 each. A market survey indicates that for each $10 rebate offered to buyers, the number of units sold will increase by 20 a week. Find the demand function and the revenue function. Demand is another word for what? Mm-hmm. All right, so let's start there. We need to have price before we can get revenue, right? So, price. We know 200 at $350 each. So, what could I do with that information? Get a point. So my X would have to be the number of food processors. So if I'm trying to come up with price, X is the number of food processors, Y would have to be the price. Okay, to write the equation of a line, we need 2 points. It says a survey indicates that for each $10 rebate, the number of units sold will increase by 20. What does a rebate do? Decreases the price. So for a $10 rebate, what would my price go down to? So my price would have to drop by 10. So the price would go down to $3.40. My X, the number of food processors, it increases by 20. So that would be $2.20. Alright, now I have 2 points, so we can get a slope. Y2 minus y1 over x2 minus x1. Negative 10 over 20, negative 1/2. Plug into y equals mx plus b, so I'll just use the first point on my slope. Equals negative 100 plus b. So price, that's lowercase p, is negative 1/2 x plus 450. That's the price, or the demand function. You could call it either. Then it wants the revenue function. How do you find revenue?
Take on your price times that.
Right, revenue is the amount of money you bring in. So it's just x times RP of x. That's negative 1/2 x squared plus 450x. All right, that's the first part it asked me for. How large a rebate should the store offer to maximize revenue? So I'm not maximizing profit this time. That means I don't need my cost or anything. If I'm maximizing revenue, that's the one I do my derivative of. So what's R prime?
Negative x plus 450.
Anytime we find maximum or minimum, we set that equal to 0. So we get x to be 450. Now x is the number of food processors. I asked you to find the rebate. The rebate is related to what? The price. So let's find the price. So if I have 450 food processors, what would my price be? So I get that the price should be $225. Okay, but I didn't ask you what the price was, I asked you what the rebate was. The rebate is the amount we dropped the price. What was our original price when we started this? $350, and we're now only charging $225. So if we subtract those, we get, there was a $125 rebate. That would maximize our revenue, the amount of money we bring in. All right, so please, when you do these problems, label what you found. Okay, especially when we get down to the end and we have to find the price of 450. If you didn't label your price function back at the beginning, that's a little bit more challenging. You have to try to rework everything to figure out what it is. So label so you know what you have. All right. Since we're going to have so many people gone tomorrow, I'm going to go ahead and do one more example today. Tomorrow, I will probably do 1 or 2 examples, depending on how we're doing, and then we'll have time to finish the homework. So those of you that are gone tomorrow, that handout on Classroom, which was only like, 7 questions or something, is due on Monday. All right, so I won't do anything new tomorrow, just a little extra practice if we need it. So, final problem for the day, so that we get through all the different types. We need to design a cylindrical can with radius R and height H. What's a cylindrical can? Normal soup can, just a. Okay. My radius is R, my height is H. The top and bottom will be made of copper, which costs 2 cents per square inch. The curved side is to be made of aluminum, which will cost 1 cent per square inch. Find the dimensions to maximize the volume of the can if the total cost is to be 300 pi cents. All right, so the thing I'm trying to maximize is volume. What's the volume of a cylinder? Area of the base. So the base is a circle. What's area of a circle? Pi r squared times the height. So pi r squared h. Can I do the derivative of that yet? Pi r squared h. We have two variables in there, right? R and h. So we need to get rid of one of them. That's where the other information comes in. We know the total cost of the can is 300 pi cents. So I'm going to use that so I can get rid of one of these variables. All right. So let's think about our cost here. You have to pay for the top and bottom. All right, what's the area of the top? Mm-hmm. And how much does the top cost me to make?
2 cents per square.
Per square inch. Good. So the per square inch, that's what tells me its area. It's 2 cents. Since this is also in cents, we can do it in terms. We can just say 2. We don't have to do 0.02 because my cost is in cents. Okay. So if I'm adding up my costs, I have to think about the cost of the top plus the cost of the bottom. All right. Area of the bottom. It's also a circle, so it's still pi r squared. How much am I charging for the bottom?
2 cents.
Still 2 cents. Then we need the side. All right. We have to think about the area of the side. So think about when you have a soup can. If you take the label off, so you unpeel that label, what shape is it? Rectangle. How do we find the area of a rectangle? Okay. The length is this distance, right? That's the distance around the outside of the circle, the circumference. How do you find circumference of a circle? It's 2 pi r. Circumference, distance around the circle.
That's what Cole just
That's what he was saying.
Yeah, that's what he was saying.
He was getting there.
Yes.
And then my height is just my h. How much are we charging for the side? 1 cent. So I only have to take that times 1. And this would equal my total cost, which was 300 pi. All right, so if I work this out, I get 4 pi r squared plus 2 pi r h equals 300 pi. I think it would definitely be easier to solve for h, don't you? So we subtract over the 4 pi r squared. Divide everything by 2 pi r. I think I'm going to do each term. That way, when I go to do things later, it'll reduce a little bit better. So h is 150 over r minus 2r. So all that work was to find my h, so that now we can go to our volume. Pi r squared h. So we plug in that h. Right. If we simplify, so if we distribute the pi r squared, get 150 pi r minus 2 pi r cubed. Now what do we do? Derivative. R is my variable, so the derivative of 150 pi r would just be 150 pi. Derivative of 2 pi r cubed would be 6 pi r squared. And we always set our derivative equal to 0. All right, 150 divided by 6, and 25. Square root, I don't have to worry about plus and minus because the radius would have to be positive. So my radius is 5. So then to answer the question, it said find the dimensions of the can. So the can has a radius 5 inches and height. If I plug my 5 back into my height, so we get 20.